Okay, so this rather interesting instrument that you see behind me here, which consists of sort of a square area here and a few cylinders around the edge, actually measures the wind profile, that is, the change in the speed and direction of the wind with height all the way to about 5 kilometers. So what you see here is somewhat interesting, because in the center here we have a vertically pointing Doppler radar. Okay, but it's not the kind of radar that you might think of as measuring weather per se. This particular radar has 3 beams. It has one beam that points directly up, one beam which points 15 degrees off zenith, directly up, but to the east, and then a third beam which points 15 degrees off zenith, straight up, to the north. And what this radar measures, what its target is, basically, are turbulent eddies in the atmosphere. So as turbulence moves by, this radar basically measures those turbulent eddies. It measures basically the electromagnetic scattering by those eddies, and it measures their velocity. And since we have 3 beams in 3 directions, we can actually compute the horizontal speed and direction of the wind using those turbulent eddies as they move along in the flow. Now, you'll see 4 cylinders surrounding this, and this is where we enter into the relatively exotic. Okay, so this radar measures these turbulent fluctuations. Actually, more specifically, it measures what we call the refractive index. It measures little subtle changes in density that occur in the atmosphere in relation to turbulent eddies. Well, a sound wave is actually a perturbation in the density. A sound wave is a pressure wave, which actually also is a density perturbation, and a perturbation in this property that we call the refractive index. So since we have a radar here that measures changes in the refractive index, we place speakers around this instrument and we propagate sound upward once every hour, basically, for just a few minutes. And we actually, with this radar, measure the speed of those sound waves as they move up in the atmosphere. Well, it turns out that the speed of sound is proportional to temperature. So by measuring the speed of sound of these waves above this radar system, we actually measure the temperature of the atmosphere. And we do that fairly continuously.
Yep, it's loud.